again to Cambridge Advanced Level Mathematics here. In today's video, we want to discuss the matrix method of solving simultaneous equations. And I do have three simultaneous equations on the board. As you can see, equation number 1 is x plus 1 plus z is equal to 3. Equation number 2 is 2x plus 1 plus z is equal to 4. And equation number 3 is x minus y plus 2z is equal to 5. Now, the first thing that we have to do here is to change this system into the new system a x is equal to b. B is a vector. So what is A? A is the coefficient matrix. In other words, it's a matrix consisting of the coefficients of x, y, z in these equations. In other words, row 1 of A will be 1, 1, 1. Row 2 will be 2, 1, 1. Row 3 will be 1 minus 1, 2. What is vector x? Vector x is equal to x, y, z. That's vector x. What is vector b? Vector b is the vector 3, 4, 5. So it's vector 3, 4, 5 here, right? So we want to change this into that. So let's see how it looks like, what it looks like, sorry. So A, of course, has got elements 1, 1, 1. Remember, we are just taking the coefficients of the variables x, y, z. So here it's 1, 1, 1. In the second row, we have 2, 1, 1. In the third row, we have 1 minus 1, 2. That is your A. Multiplied by vector x. Vector x, remember, it's x, y, z. This is equal to vector b, which is 3, 4, 5. So we have converted this system into matrix form. It's now a matrix equation. Right. The next, so let's call this step 1. Right. The next step now is to construct a matrix A stroke B. What is that? It's the matrix A in juxtaposition with vector B. So this will be our A, of course, is 1, 1, 1, 2, 1, 1, and 1 minus 1, 2. Then we put our B, it becomes 3, 4, 5. This now is the matrix A slash B. It is called an augmented matrix. Augmented matrix. The augmented matrix A. So perhaps let's call that step number 2. Now, once we get to step number 2, our next task now is to perform the algorithms that will take us to a point where our matrix AB, the augmented matrix, is in what is called but let's not worry about that. I'll talk about that when we get there. So here we are with our matrix AB, the augmented matrix. Let's start our algorithms. But the algorithms have to be performed according to a certain rules. So rule number 1 is that it is permissible to multiply a row by a constant. It doesn't change the system. Number 2, you can add or subtract a multiple of one row to another row. It doesn't change the system. Number 3, you can multiply a row by a constant. The system remains the same. Oh, sorry, that was the first one. The third one is you can interchange the rows. You can take row number 3 and make it row 1, and take row 1 and make it row 3. The system remains the same. Right, so with that in mind now, we can now proceed over here and carry out the algorithms. Okay, so here is our augmented matrix again. It's 1, let's see this I hope this pen right. Okay, so there's a 1 there, and we have a 1, and we have a 1, and we have a 3. Then we have a 2, we have a 1, we have a 1, and we have a 4. Then we have a 1, we have a -1, and we have a 2, and we have a 5. That is our augmented matrix. Now, the idea here is to have leading elements in each column. Now, leading ones in each column. In column 1, the first element there is our leading one. It's already there, so we don't need to do anything there. But once we have a leading one in a row, we want to get rid of all the elements below it first of all. So here, with our 1 here, we are fine, but we've got to kill these two guys, 2 and -1. So how do we do that? Okay, so first of all, let us write our row 1 as it is, 1, 1, 1, 3. So how do we get rid of 2? We must multiply row 1 by -2 and add it to row 2. So here, -2 plus 2 gives me a 0. -2 plus 1 gives me a -1. -2 here plus 1 gives me another -1. -6, because remember we are multiplying by 2, -6 plus 4 gives me a -2. Okay, so we have gotten rid of our 2 there. We need to get rid of this 1 here. Well, it's not a problem. We simply multiply row 1 by -1 and add it on to row 3. So -1 plus 1 gives me a 0. -1 minus 1 gives me a -2. -1 plus 2 gives me a +1. -3 plus 5 gives me a 2. Okay, so there is our new matrix. Okay, now we have a leading one here with everything below it equal to 0. So we can now forget about row 1. Row 1 is sorted. We now need to have a leading one in row 2. But this one is a 1. Unfortunately, it's a minus, so we need to make it a 1. Therefore, we should multiply the whole of row 2, by -1. So let's do that first of all. So we do, here's our, remember I'm not putting equal signs here. I could have put an arrow or something because this is not equal to that. So we can write 1, 1, 1, 3 for row 1. Now we are multiplying row 2 by -1, so that becomes a 1, that becomes a 1, that becomes a 2. And then of course your row 3 is 0, -2, 1, 2. Okay? Now I have a leading one in row 2, but I need to get rid of this guy here. So all I need to do is just to multiply row 2 by 2 and add the result to row 3. So let's do that. We have here, there is your 1, 1, 1 for 3 for row 1, Then you have your 0, 1, 1, 2 for your row 2. But we are now going to multiply row 2 by 2 and add the result to row 3. So here, of course, we have the 0, because 0 times 0 is 0, 0 times that is 0. So 2 here minus 2, that gives me a 0. 2 here plus 1, that gives me a 3. 4 here plus 2, that gives me a 6. So I now have that. I have a leading one there with everything below it equal to 0. I have a leading one here. Everything below it is equal to 0. Now, I also need to make this one a leading one, but it's a 3, so I need to divide throughout by 3. So let's do that. So we have 1, 1, 1, 3. 0, 1, 1, 2. 0, 0. 3 into 3, it's 1. 3 into 6, it's 2. Right. Look at this matrix now. It's got leading ones in every row. Okay? So there's a leading one here, there's a leading one there, there's a leading one there, and everything below the leading one is 0. This matrix now is said to be in row echelon form. So this is now in row echelon form. Okay, remember how we got here? We were aiming to have a leading one in every column, or so we had a leading one here. We got rid of everything down below. Then once we were done with that, we went on to the second row, or second column actually. We had a leading one here, got rid of everything below it. That's what we had. Here, we didn't have to get rid of anything, but we just had to multiply by 1 so that we have a leading one here. So we now have a leading one in every column. What is our next move? Now we want to get to a point where we get rid of everything above the leading ones. So what do? Of course, in row 1, here, we don't need to do that. On this leading one here, we need to get rid of this one here. So all we have to do is multiply this row 2 by -1 and add it on to row 1. So we will have 1 here, because that one is 0. Then -1 plus 1 gives me 0. -1 plus 1 gives me another 0. -2 plus 3 gives me a 1. Okay? Then I come to this one here. I'm done with this. There are no elements above it. Everything is 0. Below and above, everything is 0. Below and above. I'm left with this one here. Remember, I'm dealing with one at a time. I dealt with this, I dealt with that. Now I'm with this guy now. So here, I will have 0, of course, in row 2 here. There's a 1 here, but I need to get rid of this. So I will have to multiply this by -1 and add it on to that. So it will be -1 plus 1, that gives me 0. -2 plus 2 gives me 0 as well. Then I finally write my row 3 as it is. Okay, let's just repeat this step here. When we got here, we are now looking at this one above the leading one, so we have to get rid of it. We simply have to multiply this row by -1 and add it onto that row, and that disappears. Of course, the 1 and the 2 just vanished. So here we are now in this matrix. Look at all those leading ones. Now, this form of the matrix is called the reduced row echelon form. This matrix now is in reduced row echelon form. But look at it closely. Remember, our augmented matrix, we are coming from the augmented matrix where this part here is A, representing the coefficients x, y, z. So this will be coefficient x, coefficient y. Well, look at that. 1, 1, 1. 2, 1, 2, 1, 1, 1 minus 1. So this is matrix A. And this one here was matrix B. Now, our algorithms have resulted in this new matrix, where this is still, this is what A has been reduced to. A has been reduced to X plus 0 plus 0, Y, 0 plus Y plus 0, 0 plus 0 plus Z. Okay? This is vector B, which has been reduced from 3, 4, 5 to 1, 0, 2. So all we can do now is just read off the solution, because now it says X is equal to 1, Y is equal to 0, and Z is equal to 2. So there is the solution to our simultaneous equations. Our X is equal to 1, our Y is equal to 0, our Z is equal to 2. Okay, we can even check to see if these values satisfy the equations 1, 0, 2. So we go to the first equation there. X is 1, Y is 0, Z is 2, is equal to 3. 1 plus 2, sorry, here, 1 plus 0 plus 2 is equal to 3. Let's go to the second equation. X is 1, so 2 times 1 is 2, plus Y is 0, plus Z is 2. 2 plus 2 is equal to 4. There is the 4 then. Go to the third equation. X is 1, so 1 minus Y is 0, plus Z is 2. 2 times 2 is 4, which is 1 plus 4 equals to 5. So apparently our calculations were good. But the one word of warning with this kind of method, as you can see, there is a heavy arithmetic here. So one has to go through this step by step, because once you get something wrong here, wherever you go from there all the way up to there, you are now dealing with wrong things. So it's very important that as you do your raw operations, as you carry out your algorithms, you take care of the arithmetic with a lot of diligence. Okay, for today, that's it. Till next time, bye-bye.